Hello everyone, welcome to my YouTube channel. Today we are going to learn about digital logic and computer architecture. Let's get started. Let's start with the definitions first. Digital logic is a system of rules used in electronic circuits to make decisions based on binary inputs, zeros and ones, forming the foundation for computers and other digital devices. It utilizes Boolean algebra and logic gates like AND, OR, and NOT to process information and perform computations. Digital logic relies on the binary number system, where information is represented by two states, 0 and 1, often corresponding to low and high voltage levels in electronic circuits. Logic gates are the fundamental building blocks of digital circuits. They implement basic logical operations like AND, OR, NOT, etc. and combine to create more complex circuits. Digital logic is the basis for computers, smartphones, digital watches and many other electronic devices that require processing and manipulation of digital information. Now let's talk about computer architecture. Computer architecture is the science of designing and building computer systems. It defines how the hardware components like the CPU, memory, and input or output devices are structured and how they interact to execute instructions and process data. It covers both the logical aspects like the instruction set architecture and the physical implementation like the microarchitecture of a computer system. Some common types of computer architecture include the von Neumann architecture, the Harvard architecture, reduced instruction set computer, complex instruction set computer. Let's explain these types of computer architecture one by one. The von Neumann architecture is the most common and uses a single memory space for both instructions and data. Instructions and data are fetched and executed sequentially, which can lead to a bottleneck where the CPU is waiting for either instructions or data. Modern CPUs mitigate this with techniques like caching and pipelining. Next, we have the Harvard architecture. The Harvard architecture utilizes separate memory spaces for instructions and data, with dedicated buses for each. This allows for simultaneous fetching of instructions and data, potentially leading to faster execution. It is often found in embedded systems and digital signal processing. A modified Harvard architecture uses separate instruction and data caches but keeps main memory unified. Reduced instruction set computer uses smaller, simpler set of instructions that can be executed faster, while the complex instruction set computer uses a larger, more complex set of instructions, potentially offering more flexibility but potentially slower execution. As you can see in the diagram, von Neumann architecture uses a single memory unit for both instruction and data, accessed via a single bus. Harvard architecture, on the other hand, employs separate memory units and buses for instructions and data, enabling parallel access. Digital logic and computer architecture are closely related, with digital logic forming the foundation for computer architecture. Digital logic provides the basic building blocks like logic gates, flip-flops, etc. that are used to construct the components of a computer architecture, such as arithmetic and logic units, registers, and memory systems. Essentially, computer architecture dictates how these digital logic components are organized and interconnected to create a functional computer system, while digital logic provides the means to implement the desired functionality at the hardware level. And that will be all for today. Thank you for watching. Make sure you like and subscribe, and see you next time.